Hello, my friends. Welcome back. So in the previous video, we talked about the three main libraries that we will be using for the machine learning purposes in this course, right? We talked about the NumPy, the Pandas, and the Matplotlib library to visualize some of our results or our data sets, right? Cool. In this video, we are actually going to start with our first machine learning algorithm, and that is regression. I'm going to give you, as I promised you, a very brief introduction on what is regression and just cover the basics of the math and stuff like that. And then later in this video, we are going to actually see how we can use that in Python to predict something. Okay, let's get started. What is regression? So regression is basically the process of predicting a continuous value, right? Based on some inputs. So you have some inputs, and those inputs, pay attention, they don't have to be continuous values, right? The only thing that matters is that the output, the value that you want to predict, has to be a continuous value. So that's what we want to do when we talk about regression. As you can see in this example in here, this is like an actual data set, like a screenshot of a data set for an insurance company, that it gets the age of people, right? 19, 18, 28, so on and so forth. Sex, it is a female or a male or something, and BMI, number of children, and so on. And like it says, okay, this is like how much they have to pay for their insurance purposes, right? That's good. As you can see, age, that's a discrete value, like at 19, 18. I'm sure you can have like 18 and a half, but they don't really care about it. It's like 19, 18, 28. So this is a discrete value, right? Sex is a discrete value. It's either male or female. I mean, it's 2023. You can be anything you want. And I don't really want to comment on that. But even if you have like 4 or 5 more different types in here, that's like still a discrete value. So that is also discrete. BMI though, that is not a discrete value. Like it can be a continuous value because it can be any number. So as you see, the input features, they don't have to be discrete, right? And number of children, that's also discrete. Smoker, if they were smoker or not, that's discrete. The region in the city, like in the southwest, northwest, whatever they live, that's also a discrete value. And then based on these, you can train a model, right? You can make a model that predicts how much they have to pay for the insurance, right? So the model that you have is basically learning from all this information in here and try to guess the values in this column. Cool. So this is what we call a model. So the charges in this example, or the value that you want to predict, it's a function of the first input plus function of the second input, and so on and so forth. Okay, my battery is dying, but that's okay. So what we want to do when we talk about regression and machine learning for this purpose is we want to find the function f1 and f2. We want to find those values so that like we can describe a model. We have different classification for our models, as you can see. Like down here, we can have simple or multiple models. What that means is that in a simple model, you're basically using just one input to predict y equals a, for example, plus bx1. This is just one of the inputs. And in multiple models, you're actually using obviously more than one. It's y equals a plus bx1 plus cx2 plus, so on and so forth. We can have as many as you want. And then like another classification is linear regression and non-linear regression, right? In linear regression, well, you can have simple linear or multiple linear, right? And same goes for non-linear. But basically in linear, you have something like this. Although there is a x1 squared in here, and you may think that, okay, that this is not really a linear model, but we still count that as a linear. But like when we talk about nonlinear, it's something like this, 1 over x1, or like I don't know, e to power of x1 or something like that, right? These are the nonlinear models that we will be talking about later. But in today's video, I'm just going to focus on linear regression. Simple, and if we had time, we can also talk about the multiple. So let's see. So when we talk about linear regression, is that we basically have a line. You can see in this graph in here, we have the blue dots, which represent our data set, right? We have the x values, you have the y values. So that's a scatter plot, obviously. And then we want to find this line. We want to find the best line, right? And so this line can obviously, as you know, can be defined by two parameters, A, which is the slope, and B, which is the intercept. That's what we need to find. And when I talk about finding the best line, I could mean anything, right? You may ask me, okay, what do you mean? I'm saying like people have different metrics to define the best line, right? Some people use the mean absolute error. Some people use the mean squared error. Or, I don't know. There's like so many different features, metrics out there that you can use to, evaluate the model that you have. I personally like the MSE or the RMSE, which is basically the root mean square of MSE. People like that because it has the same unit, right? Let's say you want to predict something and the value is in meter. If you're using like meter, or like you can say foot if you're using like a imperial system. And then let's say, but for the mean squared error, that's going to be meter squared or foot squared. And if you take the foot square and make it an RMSE, then they would have the same unit, so it's easier to compare. Anyway, you can come up with your own or just like use any of the existing metrics out there. It doesn't really matter. Who's just going to talk about the basic stuff in here. And the pros of the linear regression is that it's very fast to train the model, as you will see. And it's easy to implement. It's literally one line of code. And again, you will see in a few minutes. And then there is no need really for parameter tuning, right? You probably don't even need to know much about parameter tuning just yet. That would make more sense as we talk about, more complex model. But for regression, you don't really need to worry about that. That's why we're starting with regression, because it's like one of the easiest models out there. The last thing we need to talk about before actually coding is the model evaluation. So you have a data set, you want to use that to train your data. Sometimes you train your data and test it on the same data, right? That's an approach. What happens usually, again, depending on the data set, how big of a data set that is, something may happen that we call that overfitting. And that means that your model works really well on the training data, but then as soon as you give it an input that it hasn't seen before, it fails. Like it performed really poorly, right? Just, you can imagine a student that goes to college and for the final exam, he's been reading just the examples from the previous years. So he would probably do really good if he was given the exact same questions. But as soon as they change something, although very slight in the question, he would probably fail at answering the question, right? You can look at it that way, if that makes more sense. So what we usually do is that we split the data. We use the 80%, that's like the more common one, to 20% ratio. We use 80% of data to train on, and then 20% to test to see if our data has been trained properly. And then once we're happy with that, we can actually start predicting some values. Okay, that's good. I think we covered all we needed to talk about, the basic stuff. And now we can actually go to Python and start coding. So we talked about the libraries that we need before. So let's just import them. Import numpy as np. Import pandas as pd. And import matplotlib.pyplot as PLT, right? And for the data set that I used is from the Kaggle website. I can put a link in the description and I have it open here. You can see that it's a data set with different columns, like make of different cars, right? Acura, Audi, and so on. Car model, class, like it's a SUV, it's a compact car, whatever that is. Engine size in liter, number of cylinders, and all these different columns. And then at the end of the day, we want to predict the CO2 emission, right? Which is, again, a continuous value. So this is the data set that we have. It's a pretty good data set for this purpose. Let's actually import our data set and get it here. See if we can beat that. df equals, we've seen all these before in the last video, so should be pretty straightforward. Read CSV, and the name of the CSV file, it's called the CO2.csv, right? And then we can use something that we've learned before and say print df.head and see the the first 10 rows of data. We do this and cool. So this is 0 to 9, which is the first 10 rows of the data. Okay, cool. We have our data set. And then we can do something else too. We can go, just remove that one. I can go df.columns and it gives me the name of the columns, right? Let's just clear this thing and run it. Cool. And that gave me the number of, that gave me the column names. Okay, I'm just gonna create a charge allowed up. Okay, it's happy now. Anyway, let's continue. So we have our data set loaded and we have the column names and everything we need here. We can actually start plotting something to see how our data set looks like. I'm just gonna go PLT, right? The scatter plot. And what I want to do is that, before this actually, let's do something else. I'm going to define something as selected features, for example, right? And that's going to be data frame. And inside the data frame, I'm just going to use, I'll tell you in a second why I'm doing what I'm doing. I don't really want to use all these features in here because that's too many and I have to type them all. I just want to go over the concept so you'll see how we can use regression model, and then you can keep playing with this later yourself. So I'm just going to use these 3 columns, right? Engine size, number of cylinders, and the CO2 emission, right? Let's just have that in mind. And let's now start plotting. So plt.scatter. And then we can go selected features. That the first name is this guy, obviously. So these are my X values. And the second one would be selected features dot. We can actually go with emission. See if we can actually visually see anything here. And then we can go plt dot X label. Just give it a label, right? The label for X would be engine size. Engine size, and then we can obviously do the same thing for Y label. Make that call CO2 emission. And then plt.show. That should be good enough. It says PLT is not defined. Let's see if I run this. Okay, same thing as the other day happened. I have to close. And okay, sorry about that. my VS Code crashed. I had to reopen it. So we have this thing. We define our selected feature, and now we're just like plotting one of the input features, which is the engine size, and we want to see if we can like visually see a pattern what like relates engine size to CO2 emission, right? So if I run that, it's first gonna print the columns. I don't really need that, so I can like comment it out for the next ones. And then like we can actually see the data here, right? So it makes sense. Like bigger engine sizes, they emit more CO2. So I'm expecting to like draw a line probably like in the middle or something like that. This is just like the way that I wanted to use the scatter plot so you can see that like what we talked about, the matplotlib library, so you can actually see what's going on. But we're going to comment it out for now as we won't be using it. So we talked about data split, right? I'm going to do the same thing here. So I'm going to define the mask. I'm just going to call it MSK. And the way I do that is like this. NumPy dot random dot grand, right? And this just generates random number for me. How many number I want? Lem of df, right? My data frame, which is a data set that I loaded here, has, I don't know how many rows. I mean, it's easy, like you can get the number of rows. You can just like print len of df, and that does the job. But whatever that is, I want to generate that many numbers, and I want to get like 80% of them, right? For training, and the remaining 20% for test purposes. So I'm just going to go this less than 0.8, right? This is cool. Let's see what happens. Let's just comment this out so like it's easier, right? If I go MSK equals, let's do this. And instead of len of df, I'm just going to go 10. And if I print MSK, it's actually like a really cool feature from the NumPy library. If I run this now, you can see it's giving me 10 values, but instead of random numbers, it's true or false, right? True, false, true, false, true, false, true, false, false, true, right? I mean, 10 samples is not enough, but like if he get like 1,000 samples or something, like 100 samples, you will see that like with the probability of 80%, it says like if this random number is less than 0.8, which is like 80% because it gives us anything from 0 to 1. If that condition was true, this is a logical operator, right? Then return true. If it was larger than, bigger than 0.8, then it's false. That's what we're doing here to select which data we randomly want to choose like 80% of the data for training. So I'm just going to go train equals selected features from like these columns that I have, right? Only the ones that are true, right? And for test purposes, I'm just going to go let's just copy this, put it here, and if mask was not true. See, that's easy. So this is how I basically split my train and test data. And let's continue. Now the fun begins. We're going to actually, choose a model. We want to train a model. What we need to do here is that I'm going to go from scikit-learn, that's the scikit-learn library. See, this is not a good practice. I should move the library up here, but it's okay. I'm just going to teach you something here, like you will see. But if you wanted to do that yourself, you just like move it up there. But anyway, from scikit-learn, import linear model, right? I told you I want to use a linear model before. Now we call it, I don't know, like regression, right? That equals from this library what we imported, that linear regression. It has it here. We want to choose a linear regression model, right? So this regression, that's like an object now. And we can actually start training the model, like preparing our data. We can go train underscore x, for example. That equals numpy dot as any array, this guy, as any array, train of, we want it to be a simple model, so we're just going to use one feature. I'll show you how we can use more than one feature later in the same video, hopefully. So yeah, we're going to say that the train x, the values that we want to use for training, is numpy dot as any array. So just get these values and just like bring it into numpy format for me, number array format. And then same thing for train. So I'm just going to go train apply. That equals numpy dot as any array. And then just going to go train and CO2 emission, right? So you can look at it as train X and train Y. So learn from these values, right? I want to give it these values to train on, and also like the corresponding CO2 emission value. It's also for training, right? Now that we have the values, we can go regression, the object that we had that fit, right? Train X and train Y. That's as simple as that. So what this line does, it builds a model, it trains a model based on these two, and the model is a linear regression model. And once this is done, we can actually say print, let's say fprint coefficient equals, I don't know, reg r dot, I think it was called coef underscore. So that gives us the coefficient. You remember, like we were trying to do something like y equals ax plus v, right? And a was the slope or the coefficient, and b was the intercept. So these are the values that we want to print. And so we give that, and we can also get the intercept that equals regression dot, I think it was just called, yeah, intercept. So let's see if that works. If I clear this and if I run that again, it's training the model, so it takes a few seconds, and it says, okay, the coefficient that you have is 36.92 and the intercept is 133.98. That's awesome. Cool. So I train my model, and the next thing I need to do is to evaluate the model to see how good of a model I have. So I'm just going to go from scikit-learn. Again, I'm importing something. This has to be, well, it's a good practice to keep it at the top of the file. But again, like for the sake of this video, I'm just going to keep it here. So from the scikit-learn.metrics, import R2 score, right? R2 score is a score that shows you how good of a model you have. It's anything from 0 to 1. The closer you get that value to 1, the better prediction you have. You can never get 1. I mean, sure, yeah, you can get 1, but that means either you're messing something up or that data set is just super easy, right? But anyway, you get the idea. So for that, I'm going to say, do the same thing. I'm just going to go, we have to test it now, right? So I'm just going to go test X. That equals, just going to bring this whole thing here and just change the name so that I can save some time. This is test X equals numpy dot as an array, as any array. And this is not chain. That's like the test data that we had, engine size. and this is test Y. And test Y, we do not really want to give it like, we don't want to train anything on it, right? So the test would basically be the regression model that we trained dot predict, right? We want to predict the values of test X that we define here. And now that we have the predicted values, we can actually use those to see how good of a model we have. So I can just go print MSE equals, what is the NSE? You can go numpy dot, just like do the definition, right? That's the mean value of something. Yeah, so it's like we need to do the subtraction. So that would be test Y minus, oh, we forgot something. We need to give it the actual test results as well, right? So I'm just gonna go test Y is numpy dot as any array test of CO2 emission. So we need to have the actual values actually. And then just add underscore here, just any name. You can just come up with your own name. So that minus this. So the actual value, like test Y, these are the actual values, and test Y underscore, these are what you get from the prediction. You do the subtraction, and you score the result and get the mean, and that's the MSE, right? And then you can go print, obviously, the R2 score. R2 score is, that's also easy to do. It's like R2 score, and you just give it the values, right? Test Y and test Y underscore. So based on these, it calculates the results. If I run this now, okay, it says Y pred missing the required argument. Okay, cool. We have an error here. Let's see what's happening here. It says when you're doing when you're calculating, so it gave us the coefficient, the intercept, the MSE, but the thing that it's failing to give us, it's the R2 score value, right? Let's see what's happening here. It says for the R2 score value, R2 score test underscore Y, not subtract, but this. So it's complaining about the predicted value. It says, okay, you didn't give me the predicted values because we had this minus that. So it was getting it as just like one value. So that should fix the problem now. If I clear that and run it, it says that it trained the model. The coefficient is that, the intercept is that, the MSE is this, which is pretty big, I would say, and the R2 score is 0.72. Cool. So we have a model. Like you can try plotting the line and stuff. Like you have the coefficient and intercept, right? Like you can start plotting the line and see like how it fits on your data. I don't want to really do that now, but what I do want to do before I end this video is to add more features to our training values, right? Instead of just using the engine size, and because like what we have currently is the simple linear model, right? I want to have a multiple linear model. So I'm just going to add cylinders as well. So hopefully with more data, I should be able to do a better prediction, right? So I'm just going to add that here. I'm saying, okay, if you're training, train with these two, and same thing goes here, right? And just as simple as that. You can add as many columns as you want in the data set here, and that should be good. But third point is that always adding data doesn't make it better. Sometimes you just confuse your model. Anyway, if I run this now, if you remember our R2 score was 0.72 and now it's like 0.73 and our MSE has decreased, which is a good sign. We have like a better prediction model now. And then you can see two coefficients, right? The first one is for engine size, the first feature, and the second one is for the number of cylinders, which is 9.6, and this is the new intercept that we have. We can try adding one more to see how it looks. Let's do this one, right? The fuel consumption combined. So if I add that here, well, first of all, I need to add it here. Close it, and then that, and then I'm just going to use this and add it here. So I'm just going to use those three features, see if that helped me have a better prediction. So our R2 score is 0.73, MSE is 881. Let's run this now, see if that helps. And yes, actually, it's just like much, much better now, right? You have the coefficients because you have three of them because you have three input features. The new intercept is here. MSE is almost like half of what we had before, 881 and 429, which is pretty good. And R2 score, it jumps up from 0.73 to 0.87. That's like actually a good jump. So as you can see, as we keep adding more features here, we're getting better results, better prediction values. That's all I needed to tell you about simple and multiple linear regression models. That should give you a head start if you want to start using linear regression on your own. I cannot really say that this is everything you need to know. You know, people sometimes write books and it's like 100-page book and it says all you need to know about certain topic. I never read those books. It doesn't make any sense. And sometimes people write like 10 books, each is like 500 pages, and they call it an introduction to, you know, certain topic. Those are what you want to read because I don't know. I have a feeling that those are always better ones. So I will never claim that this is all you need to know about regression and linear regression in particular, but this is pretty good. Like this is a pretty good start point for you. As always, thank you for watching me. Don't forget to subscribe so you won't miss the next video. In the next video, we'll be talking about the nonlinear regression models, and you'll see some examples there. Thank you, and take care. Have a good one. Bye-bye.